Well, I have a case study. Our case study is all about a multi-purpose hall and a dormitory building with 100 feet Divine Mercy statue. Well, the contents of my presentation is number one, we have introduction, design criteria, modeling, results, and conclusion. Introduction. The multipurpose hall and dormitory building with 100 feet Divine Mercy statue is owned by Diocese of Malolos, the National Shrine and Parish of the Divine Mercy, located in Marilao, Bulacan. It is intended to be used for the World Apostolic Congress on Mercy, or WACOM, which will be held on January 2017. The structure is a combination of reinforced concrete and a structural steel. We use MIDAS Gen as a design tool. MIDAS Gen has been introduced to us formally about 2 to 3 years ago, and did it help us? In my presentation, I'll show you some previous software experiences and how MIDAS Gen helps in designing our project. We have the design criteria. Under design criteria, we have the dead load. Under dead load, we have the material weights and density. Under that are the concrete, structure, steel, soil, and water. About the superimposed dead load, the ceiling, partition, floor tapping, plastering, and waterproofing. Under the live load, we have the roof deck, which we use a 4.8 kilopascal. Same with the function hall, hallways, and chapel. While dormitory, we use a 1.9 kilopascal. Under the seismic loop, since we are in the zone 4, we use ZS.4. Seismic source type is type A. Distance from source of the valley fault system is 15 kilometers. Salt profile type is SC. Importance factor I is 1. Response modification factor is 8.5. Near source factor NA is 1 and NV is 1 also. Numerical coefficient of 0.0731. Wind load. We have a basic wind speed of 200 kph. Mean height of 37. We have the load combination we use for concrete is the ACI 318 plus C8. In structural steel is the AISC 14, the LRFB 10. The allowable soil bearing capacity is 130 kPa at the 3 meter depth, tested done by the geotechnical investigation. Material strengths, we have concrete, we have two. We have the 3000 psi and the 4000 psi. While in reinforcement, we have FY for 12 mm and smaller, 40,000 psi. And then 16 millimeter diameter and larger, we use 60,000 psi. We have the design code. We use NSCP, or the National Structural Code of the Philippines 2010. NBC PD 1096, Implementing Rules and Regulation, Asset Earthquake Design Manual, First Edition, UBC 1997, for seismic provision, Building Code Enforcement for Concrete, Structural Concrete, American Concrete, or the ACI 318-08, and then the AISC 14 or the LRFP 10. This is our model. As you can see, we have the building is a combination of reinforced concrete and steel frame. Meshing. This is usually we encounter when meshing the plates in our previous program. It creates lots of error or warning after random analysis. While in MIDAS Gen, makes our model a lot easier, especially modeling the plate in the statue. Since it is irregular in shape, we just do a rectangular plate in every node, and it automatically snaps to the other nodes. We don't experience any error, especially in node connection of plate beam and plate. Under the node element tab, select the auto mesh icon. For this case, the method used was node. The mesh will automatically generated by selecting node's bound area. A quad triangular type is suggested for irregular meshing area. This is a structure after putting all the plates around the frame. All the nodes snap to each other easily. We have a video showing how to do it. First, go to nodes, and then auto mesh, then select the nodes, then quad triangular, then assign the property used. Then go first node, second node, then third node, then press apply. Do same procedure for the next plate. So you can also do a square plate. Press apply. So we go to the properties. We have the material. The software has a default material data such as steel, concrete, and composite with a variety of standard product, ASTM, CSA, BSO, etc. Section. We made our own section data that contains steel sections available commercially. This will avoid difficulties on the contractor side on procuring the steel section design. Loadings. Pressure load. The force applied a unit area of a surface. Different pressure load was applied depending on the fraction of the area. In applying the dead load, we exclude the weight of the slab since the weight is considered already due to the mesh area growth. So first we have to go to the load, then we have to assign a negative sign for weight. The program automatically considers the weight by adding self-weight under the load tab. Well, in our previous program, changing the load value, you have to select the plate you want to edit and replace again the load value into the command. While in MIDAS 10, editing the pressure load is so easy. Just change the value in the pressure load type and then press modify. These are the loads. We have the static load. Under the static load, we have the dead load, live load, seismic, and wind. Now, the seismic earthquake load, in our previous program, we only have earthquake along X and Y. We can get the angle of excitation of the structure. Now we have earthquake major and earthquake ortho. It is seldom we find software that can compute the angle of excitation. We use UVC 1997 as a seismic load code. To get the angle of excitation, go to the dynamic load. Edit the earthquake major in seismic load correction factor along X and Y direction. We get 66 degrees angle of excitation in X direction. We have the escape factor of 0.32556 and Y of 0.945519. Same procedure in earthquake ortho. So we have the X and Y value also. Showing this, the video also. First, we have to go to the load, then static. Go type earthquake, major, and then type is an earthquake, then add. And then earthquake ortho, same, also add. And then go to the dynamic load, then the response spectrum function. We use a UVC 1997. Change all the parameters based on your design criteria. Then press OK. And then go into the RS load cases. We have the EQ major. As you can see, there's an auto search angle. Check, and then check also the major. The escape factor is 1 over the 8.5. Then press add. Then same also, just change the earthquake to EQ ortho. Then check the ortho. Then add. So we have to run the analysis. So go to analysis and then press the perform analysis. After getting that, after running the analysis, and then go again to load the dynamic to know the angle of citation. We have the earthquake major, as you can see it is a 66 degrees, and then it also is 156. So getting that, you can use the Excel or any computation. So we have major, so it is, since it is the first quadrant, so we have the cosine 66 degrees, while the y-axis is sine 66 degrees. Same with the ortho, same procedure, 156. Okay. Copy the value in the static load earthquake, if earthquake major. So press modify. We have the seismic load direction factor. So X, since it is in the first quadrant, should be all in positive. Same also in the ortho. Same. Go to analysis, then perform analysis again. Okay, going to damping ratio for materials, we can get it in a response spectrum load case. Since the structure is a combination of reinforced concrete and structural steel, apply the damping method and choose strain energy proportional. It will compute damping for the structure automatically. In our previous program, you need to compute manually for the damping ratio if you have different materials in one structure. In MIDAS Gen, input all the material data in a group damping, strain energy proportional, for steel is 0.02 damping ratio, and concrete is 0.05. As you can see, I'll show you the demonstration. Go to load. Same with going back, as you can see in the response load. So this is the damping method. Then check the strain energy property. Same with the ortho. Apply damping method. Okay. And then go to properties. And then group damping. And then go to the damping strain energy proportional. So since we're using two properties, so steel is 0.02, concrete is 0.05. Just press add. Same with the 4000, 0.05, then press add. Okay. Then perform analysis again. To get the period analysis, we have to perform analysis. Go to the result table, view the vibration mode shape, get the highest mass participation along X and Y to determine the mode number. In the eigenvalue analysis, we can get the period in X and Y. For X direction, the period is 0.8011 seconds, and in Y is period is 0.6448 seconds. Then multiply the period in seismic load. Showing the video. After running, so you can get the result, and go to the results table, vibration mode shape, look for the mass participation of X and Y. So it is X is mode 10. Let me see. Yeah. And then same with the XY. So the period is mode 8 and mode 11. Okay. Getting the time, you have to edit the static load in earthquake major. Change, save the period analysis, we have to copy the along X time and then along Y time. Without editing the period code for that. Sorry for that accident. Do the same also in EQ ortho. Okay. Without also changing the period preferred by the code. and then run analysis. Results and design. Load combination. The software has the auto generation for the load combination, but the special feature is just check the add envelope icon. It will have an envelope load for service and strength. This example of a result output from our previous program. While in MIDAS, you can view the detailed computation of column being design, the action, the steel design. In our previous steel design, we have to group our steel section depending to its size. Steel code check checks the provided section still provided. In case it fails, you can change the steel properties in this software. It has a special feature. Choose the desired height, width, or area for choosing the section. We used MGB file in selecting our sizes. In our previous slide, we do our data section that are available locally. So the program will choose only that are available locally, update all the chains section, and recheck again. Showing the video how to do a steel design. So choose a member you want to design, then group, presses to check. There. Concrete, it checks the section properties provided shear, moment, torsion of each member. The program can provide the rebar diameter, rebar spacing, and record reinforcing steel area. The program designed the columns and beams separately, modifying the rebar so easy. Just select the member you want to edit. It will not cost you enough time. Same with the mesh design. In our previous practice, we designed our slabs, mats, footing, and walls separately using different software or program. Now we use only one software, the MIDAS Gen, to design the slab and wall. We just choose the rebar size and spacing we want. Footing design. In footing design, just put the bearing capacity, rebar diameter, and choose the design combination you want. You can use also Design Plus to designing the footing. Link the MIDAS Gen to Design Plus to automatically transfer all the loads you need. In some special design like base plate, anchor, bolt, and connection of the structures, we use the Design Plus. The program designed the base plate thickness, ray plate, wing plate, and anchor bolt. It can provide detailed drawing too. For example, how to link. Just choose the support or the node, and then go to MIDAS Gen, and automatically imported the loads. In designing the base plate, you can choose a the size of the base plate, then yes, or then just check. There you have it. You can change the distance of the anchor bolt from the edge. You just check. Okay. Connection design. Connection design of a structure steel. We use Design Plus to only bolts available in this program. Drawing is also available. Seen by that, we have a video. Just choose the member you want to check or know the number of bolts for connection, or yeah, same procedure. Bill of quantities. So MIDAS Gen can provide the materials quantities and budgetary costs of the project. Here we have the conclusion. MIDAS Gen 2016 and Design Plus software became our partner in designing and estimating. It makes our work easier and faster. Importing data of previously designed structures from another software can also be done in MIDAS Gen. Also, their technical support is very fast and accommodating. With the help of their other software, the shop detailing of software plans become easier. What's nice in MIDAS IP is they have a free training for MIDAS user and non-MIDAS user. Why hesitate to try? Thank you for listening.